let you know. It should happen in a couple of seconds. Okay, so we should be good by now. Give me one more second to switch it to your screen, please. It will help a lot. So and the screen. Yep. Yeah. Yeah, thank you, Thomas. And it looks like you have great plans. That's absolutely great. So I will switch to my presentation then, and Yeah, I have to scroll down. So now you, I guess, can see me, and I hope can hear me. Добрый вечер. And let's start. That's 5 minutes already, and we have a lot of things to discuss today. And so actually, oh yeah, that's it. Oops. Yeah, before we start, I have to ask you some questions, so I will know what your experience is and how to focus, which things I have to focus the most during the presentation. To ask questions, we use special website, you call it menti.com. It's completely anonymous. You don't have to register, you don't have to log in, don't have to put your email or anything. Just go on menti.com and put the code 4972597, or just scan the QR code. I have to hide myself, oops, so you will be able to make this, to scan this QR code. And I have to ask you 3 questions. As you join Menti, please don't close the this tab, because in the end of the presentation we will play a little game. We have a special quiz, and those who will answer my questions correctly and fast enough will earn some prizes sponsored by DataStax, some nice Cassandra t-shirts and other things. And we, I guess, are about to start. Easiest way to use Menti is just open it on your mobile phone, and we are start asking questions already. That's not a quiz yet, just a some setup questions. How much experience with Apache Cassandra? None at all. Yeah, sure, absolutely. Yes, that's a very important point. So, none at all or less than 1 year, that's a perfect point, and that's a very good place for you to start, because, well, we have something, Cassandra is not a simple thing, and you will have to learn something today, and we can proceed. So, how much experience with NoSQL databases? None at all, less than 1 year, 1 3 years, 3 5 years, more than 5 years. Okay, so I see most of you have already experience with no relational databases, or not only SQL databases, let's say, and of different experience, but most of you have some. That's already great. Cassandra is a NoSQL database, but you know this NoSQL field is huge, and therefore you have very different databases, let's say, in this field. And my final question is, what are the databases you have the most experience with? You can give multiple answers there. So I want to mention all of them. What's that? PostgreSQL, Oracle, MySQL, I don't know, Redis, or whatever you prefer to use. What's your favorites? What you have the most skills? Oracle, okay, that's pretty much expected. But you have some more for me? Okay, MySQL, DB2, PostgreSQL, Redis, MySQL wins, MongoDB, yes, I see. Okay, so looks like MySQL was a leader, but now Postgres and Redis are taking. That's an interesting distribution. So, good. Thank you for answering my questions. It helps. And now we can proceed to the next, now we can proceed to the presentation. Great. So please do not close this tab. We will use this one to play the game, play the Menti quiz. But now let's start with the important things first. So, intro to Apache Cassandra, decentralized NoSQL database for big data. Let's take a look. What is it, how it works, and why you may need that. So, Apache Cassandra is a distributed decentralized NoSQL database which you may run on a single node, if it's your laptop or anything, for a test or development environment. But when we speak of Cassandra, usually we speak of multiple nodes. So one node size is usually capacity up to 4 terabytes, although it depends on your strategy, because some companies prefer to have smaller data per node. And for output, well, that's one of the fastest databases in the world currently. It's hard to say the particular for output, but it's a lot, and it's thousands of transactions per second per core. It's a really, really fast database. Question: how nodes are communicating? Every node communicates with every node. There are no any kind of paths they follow all the time, exactly vice versa. Cassandra nodes are very smart, so they know what's going on, and they communicate with the different clusters to communicate with their neighbors and know which one is more remote, and all the time every packet goes through half of the world and delivered very slowly, or maybe this node is closer, located closer, and works much faster. It's all considered. So every node is smart, and every node communicates with every node. Nodes together united into data centers or rings. In the Cassandra terminology, ring is just a synonym to the data center. And what are the main features of Apache Cassandra? So why people prefer to use that? Which use cases are the best fit for it? First, big data ready. Cassandra works with tremendous amounts of data, and for many companies that's like a really big size. So for a long time we thought what the biggest Cassandra client, biggest company using Cassandra is Apple. Apple was using Cassandra and is still using Cassandra, and moreover developing Cassandra really hard, and their cluster was like around 170,000 servers, dedicated Cassandra servers with petabytes of data. Now we know what Chinese Huawei uses even more than that, and a lot of Chinese big projects like Alibaba, like Tencent, so well-known WeChat, is all built on Cassandra. Second point for us is highest availability. So as Cassandra is a distributed and decentralized database, there is no single point of failure, and there is no master nodes or primary nodes. All names or all nodes are equal. There is a question on Zoom: isn't Facebook on Cassandra? Well, it's a complicated question because Cassandra was developed originally in Facebook, and now Facebook is Instagram also, and Instagram works on Cassandra completely. But at this point we don't have any data on particularly Facebook using Cassandra. Although it comes from Facebook originally, now it's an Apache Foundation project. So we will speak about availability soon, and you will see how it works. Then geographical distribution. Cassandra supports multiple globally distributed active data centers. That's one of the best features for the globally distributed companies like Uber, for example. Uber uses Cassandra, or more to say DataStax Enterprise, and it uses data centers spread over the world with ease. It's a native Cassandra feature. When we always mention highest read-write performance, so ability to write or make a lot of reads per second with any amounts of data, and it's vendor independent. So it's an Apache Foundation project baked by DataStax and Apple and Instagram and Netflix and many others, but it's an Apache Foundation project. There is no chance to things happen like happened with Elastic changing their license, for example. So, speaking of scalability, one of the most important features of a Cassandra is scalability. There are two kinds of scalability we usually mention: vertical and horizontal. What's the vertical scaling? Vertical scaling requires one large expensive machine. Then your old one is not enough, you replace it with a new one, bigger one, again and again. Good points: it's easier to get than horizontal scaling. Bad sides: it's expensive, more expensive for horizontal casing, even horizontal scaling in most of the use cases, and there is still single point of failure. You still have one node, bigger node, one master node, let's say. Horizontal scalability requires multiple less expensive commodity servers. So we scale out not using the one bigger server, but multiple same size servers. It's cheaper in the most of the cases. It removes single point of failure. Problem, it's logistically harder. Good news, in the most of the cases, it's Cassandra takes care of it, so you don't have to think of anything like I'm going to have not 5 nodes but 12 nodes now. What I have to do? Your job is to add more node and tell Cassandra that's your new nodes, please reallocate data. Cassandra will do it automatically. You don't have to reconfigure clients. Still, clients will contact to the first node, ask for the schema, ask for the cluster schema, and then they will contact the nodes which is closest to them, or replica nodes, those stores data. Cassandra scales horizontally. That's clear, but there is also one big point. Cassandra scales linearly. One of the best features for me is a Cassandra linear scaling. That means what more node you add, there is zero to very low overhead on adding new nodes. And then you add more nodes, you have higher capacity or higher throughput, or actually usually both. And that works perfectly fine. In this case, I hide competitors on purpose. As an engineer, I can set up every database to be quick or to be slow. My point here is not to say what Cassandra is faster than another database name, although mostly probably it is. My point is the linear scaling. Here, more node you have, higher capacity you have, and there is zero overhead on adding more nodes. That's not only our opinion, but that was a really nice research done by Netflix engineers who scaled Cassandra up under persistent testing on the write node count, write read count, scaling from 45 nodes up to 300 nodes, and you see this really nice smooth line. That's exactly how it works, because Cassandra scales linearly. If you want to read details about this research, it was done by Netflix and published it at netflixtechblog.com at, well, blah, blah, blah. I will send you a link in the end, okay? I guess it's too long to try to copy-paste it or try to type it right now. Okay, Cassandra scales linearly. What's next? Data is distributed. It means when we work with a database like MySQL, PostgreSQL, you have all your data on a single node, and if you want to have more nodes, you may have one primary node, some secondary nodes, and if you want to have master active replication, then it means you are deep in troubles because it's not easy to organize. What's the problem here? At some point you are getting more and more data, at some point you are getting too much data. And then you have to go sharding. Sharding is painful, and if you ever did sharding with relational databases before, you know how much problems it brings. I did, and I know. So, Cassandra is big data ready. It means what it ready to support any amounts of data, and that's done based on the partitions. On the right side, we have an example. It's a table of country, city, population of the city. Very simple table. How many citizens per city we have, per city per country. And we have to spread this data, distribute this data over the cluster. To do so, we need a partition key. So, column, which will split data into the partitions. In this simple scenario, we have only one partition column, partition key. In more advanced scenarios, you may have multiple partition keys per table. I will show it to you a little bit later. So when we spread data, data is united is spread to the partitions based on the partition key value. So, for example, all the cities of the United States will go to the same partition. All the cities of France will go to another partition, but the same for them partition. So we store together what we retrieve together. And of course, every node can store more than one partition, of course. So in this case, for example, we have two partitions in one node, it's completely fine, actually. Every node stores a lot of different partitions. How partitioning work? It's very easy. First, you dedicate one or more columns to be partition keys, and then using murmur-free partitioner, the values of those values of this column will be converted into numbers or tokens. The official name is token. Every node in the cluster is responsible for the token range, so a range of tokens, and therefore every node will receive and store partitions with the matching token, and that's a very simple idea here. So, data is distributed, but that's not the only thing. Data also is replicated. What does that mean? It means what every partition is stored as many times as you arrange this to be stored using replication factor. Recommended value of replication factor is 3 per data center, because you may have multiple data centers and you may have different replication factors per different data centers. From 0 and to as much as you need, but we recommend to have 3 or 5 usually. So, replication factor 3 means what every row is stored, every partition, better to say, is stored on 3 different nodes. And the idea is very simple. Every node then responsible for the partitions of 3 different token ranges. Replication within the ring works very simply. Then you, for example, store some data. You have this data and you store, you add a new city. For example, I'm located in the city Otterberg. It's a small town in Germany, so I want to insert data. Therefore, my data will be country, Germany, city, Otterberg, value around 5,000. Let's say this value, Germany, is being hashed into the number 59. It's really not, but for example, it will be fine. Then every node in the cluster is ready to answer every question. And the data comes to a wrong node. It can happen because for any reason, a driver, for example, was not able to contact the replica node responsible for this data, and then it contacts the closest node, so this for, let's say, number 17 or number 1, as we have here 6 nodes. This node knows which nodes are replica nodes for this piece of data and redirect the query to the nodes responsible for this set. In this case, this node is called coordinator node because it processes or coordinates the query, and that's important to understand. Every node is a coordinator node. If this node would receive the query, this one would be then coordinator node, and so on. So then this node, as it knows which one is responsible, then it sends the proper queries to the nodes responsible for this data. As soon as they receive this data, they confirm what it's received, and it's all set. How it works? Then, very easy. If anything goes wrong and one of the node cannot receive the data, then coordinator node stores so-called hinted handoff. And as soon as the replica node will recover, it will ask neighbors like, okay, guys, sorry, I was down. What happened as I was down? And a coordinator sends stored hinted handoff to the replica node, and everyone is happy. That's the first layer of defense. As with distributed databases and with replicated data, we have to keep the consistency up with all the nodes. Well, then we need to have a lot of self-defense layers to keep data delivered to all the nodes, and Cassandra has a lot of them. This one, hinted handoffs, is just the first one. So, some of you already may know something and think something about that. Okay, you have replicated your data and now you got into troubles. That's like with this very simple idea. I had a problem. I decided to solve it with multithreading, and now I have two problems. So when you decide to replicate your data, you may get higher availability, but you also get the consistency problem. It's all well described in CAP theorem, or Erick Brewer's theorem, which states, in a distributed environment, in the failure scenario, out of three features, out of three qualities, consistency, availability, and partition tolerance, at any bad moment when you have problems, you have to choose, and you can have only two of them. That's very easy. Then everything works and network is good and everything is great. Then you can have all of them at once. But when something goes wrong, servers are down, network is lagging, when you have to decide what do you want to have. Main thing, you don't want your database to be not partition tolerant. If your database, distributed database, is not partition tolerant, obviously after the first partitioning, network partitioning, you will be not able to use it anymore. Then availability means what in any moment of the time you get answer. And consistency means what in any moment of the time you get the most up-to-date value if something changes. And in any moment we have to decide if we want to be here, available and partition tolerant, or if we want to be here, consistent and partition tolerant. That's just like a law of physics. You cannot change it. But let me show you how we can handle that with Cassandra, because, well, we want our data to be available and consistent and partition tolerant all at once. How do we get that? So, some people say Cassandra is available and partition tolerant, but not consistent or eventually consistent. Personally, I don't agree with that for a very simple reason. Cassandra is configurably consistent, and in any moment of the time you can specify which particular consistency level you want to have right now. Idea is very simple. Executing a select or insert statement, whatever you want to do, query your data, update your data, you can specify consistent level you want to have. Idea is very simple. That's configurable. Default consistency level is quorum, but you may also have any 1, 2, 3 quorum all. What does that mean? Any means what? Then you write your data, for example. As soon as it reaches any node, you don't care if it's a replica node or coordinator node. As soon as it gets your data, you receive the confirmation. It's the fastest way, but it may be not reliable, because if this node what got the request is a coordinator, not replica, and something bad happens afterwards, immediately in the same moment, then your data will not be for real stored. If you bring your data, if you bring this node back, when okay, it will send hinted handoffs to all the other nodes. It will replay the log and you will get your data. But if this node is gone forever, your data is gone forever. So any, in the most of the cases, not recommended consistency level. 1, 2, 3. It means amount of the confirmations you need from replica nodes, nodes responsible for your data, amount of confirmations you need before you proceed. Then, quorum means the majority of replica nodes. For example, if you create it all with replication factor 3, majority will be 2. If you create it with replication factor 5, majority will be 3. If you create with replication factor 2, majority will be, try to guess. And actually that's interesting. Try to guess what will be the majority, what will be the quorum for replication factor 2. No, not 1. It's still 2, because out of 2, 51% round up will be 2. That's why we recommend to use numbers like 3 or 5, not 2 or 4, because for 4 nodes, 4 replication, 4 replica majority still will be free, but it will be same for 5 nodes, for example. So you can afford losing more nodes, still keeping your data available. So if you have consistency level quorum, and if you have 3 nodes and 1 is down, you query your data, 2 nodes, majority is up, you get your data. Yep. And let's take a look at that. Stop. Cassandra is a multi-DC, multi-data center system. So there are 3 more consistency levels you have to understand. Local one, local quorum, and each quorum. So take a look. If your application runs in the United States, Australia, and Europe, and your data is located in the data centers in the United States and Australia and Europe, you want for your European clients work with your European application and European data center, correct? Of course, it makes no sense for them to work with the Australian data center. So local means what for this particular instance of your application, this particular data center will be considered as the closest one. Then you start up an application, you can specify which data center is the closest one, and therefore it will prefer to use with this data center, obviously. And then local one means what you will wait for the confirmation from one replica node out of this local data center. Your data will be automatically spread over the world. But if you are going to wait for each quorum, obviously it will wait for, you will have to wait for the quorum in every data center you have. And if you have 3 data centers, you will wait overall for all of them, even for the most remote. So each quorum is a good choice when you work with highly important data. But it also can be the slowest way. In the local quorum, you will wait for the confirmation only of the quorum of the replica nodes of the closest data center. So, with consistency level 1, as I said, it's very simple. When data comes, it's being distributed to all the replica nodes, and you wait only for 1 out of all replicas confirmation. As soon as you get the first one, confirmation is immediately returned to the client. We are all good, we got your data. Your data will be stored everywhere, but we wait only for 1 confirmation. Of course, it's asynchronous process, which is very fast. So I see there is a question from Philippe. I will answer this one after the workshop, okay? Well then, yeah, and that's an example with consistency level 1, replication factor 3. With consistency level quorum replication factor 3, we will wait for the majority of the confirmations. What makes 2 for replication factor 3? And for consistency level all, we will wait for all replica nodes to confirm they got the data. But there is a problem, because CEP theorem is still here, watching you, always watching you, waiting you to make the mistake. And the moment you set consistency level all, what happens? Let me scroll back and remind you. This slide, what happens when we set consistency level all? Very easy. We migrate from availability and partition tolerant to full consistency and partition tolerant. That means as long as a single node cannot answer your question, boom, you got an exception. Sorry, desired consistency level cannot be reached. One of your nodes is unavailable or down. Oops. So, that's a very important point. Cassandra is configurably consistent. And that's a configuration per query. That's what I really want to highlight. The same application may work with highly important data. You don't want your bank to run your transactions in a not consistent way. Yes, but there are also many applications working with, let's say, secondary importance data, which you find if you are getting outdated. For example, if a friend of yours at Facebook changed his or her profile picture, and the same second you open like Half second later, you open his or her page and you got the old picture. Will you survive that? Well, I think I will. And that's perfectly fine. So within the same application, depending on the importance of your data, you can specify different levels of the consistency. And now here comes one very nice trick. If consistency level all is very bad for us, doesn't matter how many nodes we have, even if we have replication factor 5 and we lose one node, we can't retrieve our data anymore. Do you call that high availability? I don't. With consistency level quorum, I can lose 2 nodes out of 5 and still get my query. Well, when you have 2 nodes of 2 servers out of your 5 servers down, that's pretty bad situation, but even under best circumstances, your Cassandra may work. So, what are the solutions here? Are there any better ideas? There is a thing called immediate consistency. And immediate consistency is a great concept. Basically, we want to have our data available. But if we require consistency level all, when we got into this trap of a single failed node brings us to a problem. How do we get into the middle of these CAP circles? Because, well, we want to be there. Immediate consistency is the best way to get there. So, when I write data, I specify consistency level quorum. That means what I wait for at least 2 confirmations. In good scenario, 3 nodes will get the data. In the bad scenario, 2 nodes will get the data at least. Or if I have somehow 2 out of 3 nodes not available, I at least will be informed what operation is not possible. Okay, that's fine. I know what data is still consistent. I know what problem happened. I can work with. So I wait for 2 confirmations. Good. When I'm trying to read for the data with consistency level quorum, and client tries to read, and there are 2 options in the bad scenario. Query first answers can be delivered from the 2 up-to-date nodes. Well, then answer is delivered immediately, and that's a correct answer. But what happens if my read query first 2 answered nodes, one was updated and stores correct data, and one wasn't updated and stores outdated information? What happens then? Idea is very simple. Here comes the second defense layer of a Cassandra, call it repair on read. If during the read operation Cassandra notices what 2 different nodes or 3 or 5 different nodes returns different values, it will automatically execute repair and recover the system to the consistent state and will return most up-to-date data to the client. And you will, if you don't read logs, if you don't have monitoring configured, you will never even learn about that because it's fully automated. So here comes repair on read. There are still more layers of inconsistency defense, or consistency defense, better to say, but that's how it works. That all about simple idea, a simple mathematical idea. With immediate consistency, if your consistency level of write plus consistency level read higher than your replication factor, you get immediate consistency immediately. So very, very simple. We have replication factor 3 and we have consistency level write quorum, which means 2, and consistency level read quorum, which means 2. 2 plus 2 is bigger than 3. We have immediate consistency. There is no possibility to get outdated information. That's not the only way, because, for example, if you make consistency level write all equals 3 and consistency level read equals 1, so 3 plus 1, 4 is still bigger than replication factor. That makes your reads very, very fast because you don't wait for confirmation at all. You get only one answer and immediately process that. It's the fastest way. But then you have danger on write time because, well, of the CAP theorem. You write with a consistency level all, one node is not available, you cannot write. That's not the most common scenario, although people are using that. For example, I know one company having 2 two different data centers, one for processing of real data, let's say, for customers, and one for analytics. So they were distributing their workload. They were moving data from one to another with consistency level of write all once per day in the morning, and then during all the day we did not more write operations for analytics in the analytics data center, only read. In this case, they could use consistency level read 1 and get all the data very quickly and still have immediate consistency. And vice versa, you can have consistency level write 1 and consistency level read all, have consistency level overall 4, higher than 3, and have immediate consistency. But that's obviously not the best recommended scenario, definitely. Default consistency level is quorum. If you don't change it, it will be quorum. It means you always have immediate consistency. So, people say Cassandra is eventually consistent. I don't like this. That's not perfectly correct. Cassandra is configurably consistent, and you decide which level of a consistency for which kind of data you want, because it's per query setting. Next thing, data is distributed everywhere. So geographic distribution, you can have multiple data centers, let's say, but also it's platform agnostic. So you can run it in Microsoft Azure, AWS, Google Cloud, and your own on-premises data center at the same moment of the time, and those different data centers will still build the single cluster working together. In this case, if you have configured it all correctly, you may afford losing a whole data center, still getting your data back. So, speaking of the use cases, what are the typical use cases for Cassandra? Everything what relates to scalability and highest workload, high output or high volume, heavy writes, heavy reads, everything what relates to very intensive operations and thousands and thousands and thousands and millions of operations per second. That's a perfect case for Cassandra. Availability, the same. For any kind of a mission critical workload, you've seen with replication factor 3, you can afford losing a server. With replication factor 5, you can afford losing 2 servers and still be available per data center, or maybe even more if you have more data centers. No data loss, always on. For any kind of a data you may want to have, it's there. Then, next thing we mentioned, it's distributed. For any kind of a global presence and workload mobility, you may have your data everywhere at the same moment of a time, active, and you don't have to take care of that because it's a Cassandra job to replicate your data. But we also speak about compliance in GDPR. You can set a replication factor and per data center. You will see it in a moment. And therefore, for some of the data centers, replication factor can be 0. It's perfectly fine. And then you are good if you don't want to store data of your European clients into the United States data center. That's perfectly fine. And everything what relates to global companies having clients everywhere. And next thing and last thing is everything what relates to cloud native and modern cloud applications. Cassandra perfectly works in a distributed networking environment. Cassandra perfectly works in the case of a multi-cloud and hybrid cloud, have mechanisms of self-recovery and able to support hybrid cloud, multi-cloud at once. Okay, so as few words about the structure of the data in Cassandra. It's a table-based, white column-based and table-based database. It's not Mongo, which is schemaless. You still have schemas here. So, simple, the basic unit, the smallest unit of the data is a cell. Intersection of a row and a column with a data inside. Then, row is a structured single data item in a table. ID, first name, last name, department. Then something new comes, what I've mentioned before and I want to mention again. Data structure partition. It's a group of rows having the same partition token. And that's a base unit of access in Cassandra. That's very important to understand. When you work with a normal traditional relational database, you have database, when you have table, when you have rows. You don't think of anything else. Well, as long as you don't have shards. Then, with Cassandra, you have Keyspace, so container for tables. Then you have table when you have partition, when you have rows, and that's very important to understand. And when we have a table which consists of partitions based on columns. So overall data structure is a key space having tables and table having partitions with columns within. Example data here is users organized by city. So in this case, I partition my users based on the city they are located in, and that's not the best strategy. I will explain you why, but it will work at first at least. And we have partitions and partition key columns defining those partitions. When we have clustering columns, I explain in a minute. And finally, I have data columns, and well, it all consists of rows in the end. When I create the Keyspace, Keyspace is the first thing we start to play with. Keyspace consists of a very simple set of properties. First one is going to need the name, pretty much expected. And it may have a lot of different configurations, but one is really important for us is replication strategy. So what's the replication strategy is? That's the strategy which will define the data allocation within your cluster. And there are only two strategies: simple strategy and network topology strategy. Simple strategy is good for your laptop and bad for everything else. It's very simple. It's only for your own development scenario, let's say. Network topology strategy, as it states, it's a network topology aware strategy. What does that mean? Idea is very simple. We're working with your data center. You have servers. Servers are into the racks, and racks are into the data center. So you may have two data centers, for example, but still there will be some racks, and still there will be some servers. If you work with a cloud, you may have, therefore, not servers and racks, but you will have some nodes and you will have availability zones. In this case, Cassandra considers availability zones as racks. Why does that matter? Because by default, Cassandra tries to distribute your data in the way what replicas will be not stored together. Very simple idea. If you have multiple racks and you have some servers in a single rack, they tend to fail together because of a network or power outage. So Cassandra tries to put repartitions of your data, replicas on your data, into multiple different racks or availability zones absolutely automatically. You don't have to take care of that again to reach the maximum possible availability of your data. And then finally, for the network topology strategy, we define replication factor by data center. United States West 1, I want to have free replication factor 3. For the Europe Central 1, I want to have replication factor 5. That's pretty simple. And then you may have, I may have 3 data centers. I don't mention this one here. It means what my Keyspace user will not be allocated to the data center number 3, whatever it is, Asia Central 1. Again, doesn't matter. Then I create a table. I have to allocate some values here. Again, table creation is very simple. Create table, Keyspace, users by city, so users partitioned by city. With city text, last name text, first name text, address text, email text. Okay, too much texts for me, but it's fine. And when I define primary key consists of 2 parts: partition key and clustering columns. Clustering columns are optional. Partition key is required. Without partition key, I cannot partition data, and therefore I cannot store data because I don't know which server to use to store it. What's the job of a primary key? Primary key job is a very simple idea. It must be unique identifier for a row. For example, if I build my primary key to be like that, city, partition key, last name, first name as clustering columns. Therefore, primary key of every row will consist of a city, last name, first name. What's wrong with this scenario? Well, I have a lot of John Smiths in New York. Actually, I did a little check. That's about like a couple of dozens of them. So basically, Cassandra uses upsert, which may be familiar to you. And therefore, every next John Smith will overwrite data of a previous John Smith, and he will not be happy. Very simple. How do I solve this problem? I add one more value to the primary key. So this one is the example on the same data: city, last name, first name, email. In this case, I don't need email per se in the primary key, but I need it to ensure uniqueness, because amount of John Smiths in New York with the same email isn't going to be too high. Another option would be if I just store the list of the users without partitioning by city. My primary key may be user ID. As long as a user ID is unique, I will have as much partitions as I have users, and that's perfectly fine. Number of partitions, it's not a problem. So you may have one partition per one row in the table, and that's perfectly fine. The main job of a primary key is to ensure uniqueness. Then, partition key. Partition key, we discussed it a lot already. Partition key is an identifier for a partition. It consists of at least one column, might have more if you need that. So, as said, a typical idea: primary key, user ID. I will be able to query my users if I know the user ID. Or, primary key, video ID and comment ID, given we are storing comments for videos and the YouTube. So we have YouTube, we have videos, we have comments. I may store comments like that. I will spread them into the partitions by video ID, and that's a good idea. Store together what you retrieve together. All the rows with the same partition ID will be stored together and will be retrieved together. It's easy for them to retrieve. I have to ask one particular node, not try to combine them from multiple different nodes. So that's a simple idea. That example from IoT we will discuss in details later, so I will not discover it for now. Give me a moment. And finally, clustering columns. They are used, as you know already, in the primary key to ensure uniqueness, but they have a second job, which is they define sorting order. So partition key has only clustering column has two jobs. They needed to ensure uniqueness and sorting order if you need sorting order. So, as said, our problem here, primary key, city, last name, first name. As soon as we got the second person with the same name in the same city, we have troubles. So we solve that. City, last name, first name, email, problem is solved. But also, second scenario, video ID, comment ID. It will work, they are unique enough, but they are not sorted in this case. And we want our comments, when you open YouTube video, you want to see the latest comments first. Well, mostly probably you don't want to see any comments at all because they are mostly bullshit. But still we have to show latest comments first. So in this case we are using video, created at, and comment ID. Created at isn't required for uniqueness. It's required for sorting order. Now, we are getting to the end of this presentation, and I just have few last slides, but those slides are the most important. They even have the slide of a year award. I created them and they were so great, so I decided to give them this award. So that's an award from me to my own slides. That's a little bit selfish, but they are really, really, really important. Rules of a good partition. Store together what you retrieve together. Open a video, get all the comments with a single query to a single server. Then you have them stored by video ID. I don't store my comments per video based on their comment ID. Because take a look. If I don't specify partition key in my select statement, what would happen next? Cassandra doesn't know which node to ask. If you have 3 nodes on your production cluster, it's acceptable. If you have 300s, 3000s, 3 dozens, thousands nodes, you are literally going to ask every node, do you maybe have a comment for the video number 15, 16? It will take ages. So let's call it full cluster scan. Our idea is to always avoid full cluster scan and therefore always specify partition key. It's very important. Second rule of a good partition, avoid big partitions. So in this case, we have video ID, created at, and comment ID. Comments will be partitioned by video ID. And you know what? There can be really a lot of the comments per video, which kind of looks like a violation of this rule, but it isn't really, because what really matters is the size of a partition. I mean, like physical size, megabytes, kilobytes, and so on. And there can be really a lot of the comments, but they are just a user ID, a video ID, created at, and text. So just some minor sizes. They will never be too big as they are. But the general idea is up to 2 billion cells per partition, the general recommendation. Up to 100,000 rows in a partition. That's not a strict limit. You can have more if your rows are small. It's fine. Up to 100 megabytes in a partition. Again, you can have more, but it's not recommended. 2 billion cell is a hard limit. And what's wrong with this example? Country, user ID. Idea is very simple. You will have some countries are like I don't know, give me an example of a small country. Like in Europe we have a lot of them. Something like San Marino, you are going to have like, or Vatican. How many people, yeah, Luxembourg, how many people live in Luxembourg? How many people live in Vatican? Those are going to be pretty small. And meanwhile, imagine India or China, and there's going to be imagine you have San Marino in China. It's going to be 2 partitions with 20 people in one and much more, very different number in another one. So what's the point? Try to partition your data to be reasonably big, not too big. Then there is a trap. So I told you there is a problem with this example. Let's take a look. That's a real example from one of our clients, a huge telecommunication company with a lot of infrastructure all over the world. Imagine a network of sensors reporting their state all the time. Every report is very simple. Sensor ID, universal unique ID, timestamp, so when it happened, and value. What's the value of this sensor? It can be temperature, it can be humidity, it can be network output at the moment, and so on. And every of them report their state every 10 seconds, and you have billions of them. And at first, that's a real example, as I say. At first, we have a table like that. Sensor ID is a partition key, reported at as the clustering column to have them sorted and unique. Please try to guess what was the problem and when it happened. The key word is when. Actually, it would be great if you could answer that in Zoom chat. Okay, Naveen Kumaran, I see your question on the YouTube chat. I will answer after the main part of the workshop will be done, of the presentation will be done. So, after 2 billion sensor values, well, yes. So, the main idea here then like two sensors reported different values at the same time. No, it's not a problem because different sensors will have different sensors ID. The problem in this case is what those partitions are always growing and growing and growing. In the beginning, it will work fine. But after some months, as we report data every few seconds, all the partitions will be just too big and it will be hard for Cassandra to handle them. To address this problem, we introduce a new solution, call it bucketing. As I've mentioned before, partition key may consist of multiple columns values. In this case, we are adding one more syntactical column, call it month year. And that's just an integer or a string that doesn't matter. That's a syntactical thing to organize bucketing. Now we have February of year 2021, therefore our month year is going to be 022021, February of 2021. On next month is going to be 032021. When we add this month year to a partition key, we have therefore partition key consisting of the two values, sensor ID and month of a year. Combined together, they will give different partition token, and therefore data will be allocated differently. As soon as month is over, you will start to write to a new partition, and your partitions will be never too big. That's very easy. Now, I know what usually a lot of people on this example ask, but why can't I use just date? So 9th of February of 2021. Why? Answer is very simple. You can, and it will work, and it's not bad. But it brings one more problem to solve. Take a look. When you query data, you must always specify full partition key, no inequalities. So in this case, if I have to query data for today with the date, it will be easy. I give sensor ID and today, and I get my data. It's fine. But if I have to query data for a month, for 2 months, for 3 months, no inequalities, I have to say, okay, give me data for sensor number 12 for today and yesterday and day before yesterday and day before yesterday, and so on and so on and so on. I see a question in the chat. There will be too many partitions and there would be just date. No, it's not a problem. You may have as many partitions as you want. That's not a problem. You can afford having billions and billions and billions and billions and billions of partitions. But when we have these day-sized partitions, if we have to retrieve data for multiple days, we have therefore to specify all of those dates in our select statement. It ain't going to be convenient. Now, if I have to query data with this example, sensor ID month year, if I'm going to query data for all the days in year 2021, I have to do select from where sensor ID number 12 and month year is January of 2021 or February of 2021. Pretty easy. And I will get this data. How about sensor ID, month, year reported at? Yes, it should work as well. So I don't see any problems using month, year as separate part of a partition key. It should work as well. It just, from my point of view, makes your select statement a little bit more but yes, it will work. It's pretty good solution. Okay, so we are out of time and we still have a quiz to run, so I'm getting to the end of the slides. Finally, avoid hot partitions. As said before with the example of country and user ID, in some countries you have like 100 people, and some countries you have very, very different numbers. If you spread your customers based on their country and you start to sell your goods in China and you are successful there, congratulations, but now you are deep in shit with this data model at least. This scenario with primary key video ID of a partition key, so that's a video and comments to video on YouTube, Is it a good or bad example? That's acceptable. Because take a look. We, of course, every video have different rate of comments per moment of time. Yes, so just released video of, I don't know, whoever, Beyonce, may get more comments than whatever other video we talk about. But again, as they have a lot of videos, those videos have different IDs. They will be spread over multiple servers, so you will not get a situation when one server is busy, others are idling. That's what important to avoid. If you have, doesn't matter if you have 1000 server cluster and you have replication factor 3 and one partition is hot and others are idling, you will have 3 servers overloaded and others are idling and your data model is not efficient. Very simple. So we made it to the end and now it's time to play a game, and after that I will be able to answer your questions, okay? Oops. Wrong side. Yeah, perfect. So let me start. Okay then. Yes. So quiz time. I'm waiting for players before we start, and we have some questions, and we want to answer who answers the quickest and correct way. You will get top 3 places, actually top 3 places are getting prizes. And of course, to say many thanks to the organizers, we have something special for them as well. But you still have to participate. That's a lot of fun in the competition, you know. Good, so I see 13 people. That makes everyone is able to win because we don't have too many people today. 14. Okay, give me one more and we start. Give me 15 people in the competition. So every 5th will win 13. Okay, 15, yeah. We are here, so we can start. So, answer fast to get more points. How many master nodes does Cassandra require? At least 3, known Cassandra is a masterless system, enough to maintain consistency, 3 per data center. And time is up, and let me see your answers. And correct answer is Cassandra is a masterless system. There are no master nodes, there are no server slave nodes. It's every node is equal. Every node is a replica node, and every node is a coordinator node. All of them have the same duties. They're responsible for the different ranges of data. That's correct. But all of them have the same duties. There are no master nodes in Cassandra. So, we have a lot of questions today, so you still have the chances. Let me see the answers. And Vribeiro was the fastest one. Congratulations. And we have Hoblin on the 2nd place, and oh, I'm sorry, Grzegorz on the 3rd one. I hope I pronounced it right. Sorry if I'm wrong. And we have some competition here. So there is a question too, and answer fast to get more points. In Cassandra, how is data distributed? Partitions. Data is copied to every node. Address locators through the mail. That's a good question. So, how is data distributed? Or based on what data is distributed, I would say. Time is up, and the correct answer is partitions. Take a look. Data is copied to every node. 2 people gave this answer. It means I'm going to be fired tomorrow, because everyone should have answered partitions. If you have data copied to every node and you work with a dozens petabytes like Apple does using Cassandra, it's going to be like too much expensive even for them to store all of the data. Data is distributed based on the partitions, not to every node. Yeah. And the leaderboard Ribeiro or W. Ribeiro gave the right answer, but too slow, and Grzegorz gets to the first place. Great job. That's amazing. Then with only 5 points difference, that's a couple of microseconds, Hobling is getting second place, like last hold. And W. Ribeiro, or V. Ribeiro, I'm sorry, is on the third place, and that's a really good result because first 3 places are getting prizes. And then we have Mike, Rahul Jangra with the fastest answer, Nikolaus and Tommy, and there are some more people getting closer and closer to the winners. Let's see how it goes in the next questions. Question number 3. Answer fast to get more points. How do you scale up a Cassandra database? Add faster hardware. Increase the scale factor. Add more nodes. Stack nodes until they reach the desired height. Yeah, I see Grzegorz, I'm very happy. I did my best. Time is up. And the correct answer is add more nodes and add faster hardware. It's a vertical scaling. And Cassandra prefers horizontal scaling. So, what are the changes we are going to have? None of the leaders made a mistake, but there are some changes based on the fastest answers. And Ribeiro gets to the first place. That's great. Then Hoblin is on the second, still holding the second, like that's a stability sign of a success. And Grzegorz gets to the third one again, but we know how easy it can change. Rahul Jangra is on the fourth, getting ready to jump in to the third place, like so. Stay ready, there are some more changes coming in. And next question. Answer fast to get more points. What is the recommended replication factor? 7, 3, 42, 1. Who needs more than one node? So this one must be easy. This one must be easy, I guess. 3, 2, 1. Time is up. And the correct answer is 3. Recommended replication factor is 3, so you can afford losing one node completely and still will be able to answer to any question with consistency level quorum, which is recommended. You can also have 5, which is also a good number, but usually we don't recommend go higher. Okay, so this one was simple. What? Okay, okay, that was unexpected. Ribeiro makes a mistake. Snoopam was the fastest one, getting into the top 6 of the participants. That's a very nice result in the middle of the quiz. Hoblin gets to the first place. How could you? You should have stayed in the second one. Like, what about the stability? But okay. Grzegorz gets to the second one. And Rahul takes his chance and gets to the third place. And that's great, ladies and gentlemen. Okay, so next question. Answer fast to get more points. A Cassandra database can be deployed on AWS only. Any combination of on-premise and cloud provider. Only one of the following: on-premise, AWS, Azure, or GCP. Can be deployed on a live raft in the case of emergency. Now I'm all curious on the answers. Yo, not a single doubt. Any combination of on-premise and cloud provider and still be the same cluster. It's completely platform agnostic. And who was the fastest this time? Who gets the label fastest? Who is here? Okay, MRZ was the fastest one, getting to the 7th place. Grzegorz on the first, Hoblin on the second. Okay, and Rahul Jangra holds the third one. Very good job, but stay aware, there is a Nikolaus very, very close to you. Well then, question number 6. Answer fast to get more points. The CAP theorem states what in a failure scenario with a distributed system, consistency, availability, and partition tolerance are all achieved. Only availability is achieved. Only 2 of the 3 guarantees are achieved. I should probably buy a new cap. So, I hope this one will be harder. It was too easy to you, at least for most of you. Yes, CEP theorem states what in a failure scenario with a distributed system, only 2 out of 3 qualities can be achieved. Or partition tolerance and high availability, or partition tolerant and consistency. That's why we make a decision. And there are 3 people answered what consistency, availability, and partition tolerance are all achieved. I want to ask you, that's the land of unicorns and rainbows. Could you please send me a ticket to your land? I want to live in the land the CEP theorem works this way. I really want to live there. So, who was the fastest and who made a mistake? Oh my god, Rahul! It was such a nice attempt. But I guess now it's, yes, go to the 7th place, I'm sorry. So, Grzegorz gets to the first one, Hoblin is on the 2nd, and Nikolaus uses the mistake of Rahul and gets to the 3rd. Well, and we are getting closer to the end. Answer fast to get more points. The recommended way to achieve immediate consistency is to use read-write 1-1, read-write 1-all, read-write quorum, or with a video chat between coworkers. It's gonna be pretty interesting on high-load operations. I would love to see that in action. But the correct answer is simple, quorum. With read-write 1-all, you do reach immediate consistency, but it's not the recommended way, because recommended way, as I stated before, quorum. So let's take a look at the results. Does any one of the leaders made a mistake? Oh, that's unbelievable! Take a look, such a competition till the end. So Nikolaus makes a mistake and Mike jumps to the 3rd place. And Snoopam is on the 4th already with again fastest answer. That's great, so we still have competition in the leaders list. But on the 1st place we have Grzegorz and Hoblin and Mike in the top 3. Okay, and take a look, Rahul is not so far away. So there is still a competition and everyone has a chance to win. Few last questions, ladies and gentlemen. Answer fast to get more points. A keyspace. Keyspace. What is a keyspace? Is organized into rows and columns. Contains tables and sets replication. Is the base unit of access. Is a place to store extra house keys. What would you answer? Okay, so Keyspace contains tables and set replication. Keyspace is not the base unit of access. It's a partition. And Keyspace is not organized into rows and columns because Keyspace contains tables. That's the correct answer. So let me see the results. Oh my god, I can't believe. On my memory, this quiz is like the one that tends to change all the time. Grzegorz kills the 1st place and Mike gets to the 2nd and Hoblin is on the 3rd and MRZ was the fastest one getting the 4th place. And take a look, there is a familiar name with 5,781 points. Call it Ribeiro. Welcome back to the top. We aren't done yet, but you have all the chances to get in. Question 9. Answer fast to get more points. In Cassandra tables, which are required? Data columns, clustering columns, partition keys. That makes me very curious if it was like patient enough to get my answer here. Was it good enough? Was my explanation good enough for you to get that? Time is up. Require it. Partition keys. Clustering columns are optional. And let me see the people who answer it correctly. Does any of the... Okay, that's not expected. It looks like there are some changes again. So Grzegorz was the fastest one, holding the first place. Very strong. Hoblin on the second, and third is for Mike, and Emerzit is very close to that, and Snoopam is on the fifth. Let's take a look how it goes then. Like, you people make me nervous, and we are in the end of the quiz. Answer fast to get more points. In Cassandra, tables hold many partitions, only rows and columns, replication factors, endless sea of hopes and dreams. What would be your answer here? I can't wait to see. That's very, 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 very interesting. Correct answer is partitions. Correct answer in partition. That's not a relational database. You use it to use schema, table, rows. No, partitions. Think of the partitions. It's very important. Okay. And I want to see the results after this one. Oh my god, I can't believe that happened. Okay. Grzegorz, despite the wrong answer, gets to the first place. MRZ gets to the second one with the fastest answer ever, and Hoblin holds the third one with Jerzy Balwinski very, very, very close with 600 points difference. It's not simple to jump over 600 points, but it's possible. It happened before. That brings us to the last question of this quiz. Take time, breathe in, breathe out, warm up your fingers, prepare as we are starting the last question, and 3 winners will get the prizes. Answer fast. How does Cassandra perform joins? Cassandra joins require a join table, just like SQL joins. Cassandra does not support joins. Cassandra only joins clubs. This one is very, very, very obvious. This one is very simple. Cassandra does not support joins. That's the price what comes when you work with petabytes over thousands of nodes. There are no joins. And the correct answer is no joins. And that brings Grzegorz to a second mistake in a row and basically wipes out the first half. Oh my god. That's incredible. I love you. That's such a competition this time. Hoblin, congratulations. You got to the first place in the end. And MRZ on MRZ, I don't know. With 8,538 points, get to the second one. And Grzegorz holds the top 3. That's enough to get the prize. All the prizes are the same. So it doesn't matter if you are top 1, top 2, or top 3. If you didn't make it to the top 3, don't be too sad about that, because what's the most important is your knowledge, your skills. Today you learned one of the most powerful databases in the world, so you learned a lot of very important things. In the final end, that makes you better expert and raises your salary, because Cassandra is used on the biggest companies over the world. It definitely may help you to secure a higher money in your pocket in the end. So that's the knowledge is prices. That's what really matters. To the winners, please write to me. I will send you an... You know what? I will send you a link actually to my LinkedIn. That's my LinkedIn. Please, we spent 1 hour together, actually even more, almost 1.5. Sorry for that. And we did so many things together, so now we are like colleagues. So please add me on LinkedIn. It's always great to make new friends. And for the top 3, send me your email, t-shirt size, and post address, so we will send you the prizes. If you by any reason don't use LinkedIn, so here is my Aleksandr VOLOCHNEV at datastux.com. That's my email, and therefore you can use this one to get your prize. And oops. Yep, let me send it Twitter. Well, I have Twitter, but I don't use it too much. Good. And basically, that's it. So, that was Intro to Cassandra with Aleksandr VOLOCHNEV, developer advocate at DataStax. We have some recommendations for you how to get more learning in Apache Cassandra field. It's all free and available at datastax.com/dev or at the DataStax Academy. And the most important announcement here, tomorrow we have a very special workshop coming in that's a very important thing in Cassandra, to create an official data model. And I want to recommend you a free workshop happening tomorrow evening and the day after tomorrow morning. Call it Advanced Data Modeling. There is a great guy, call it Artem Chebotko, Dr. Artem Chebotko. He is a creator of a data modeling framework for Apache Cassandra. And I highly recommend you to attend this workshop, to meet me again and to meet Mr. Chebotko, to learn from them, from him, and well, a little bit from me as well. How do you design successful data models for highly loaded applications? It's free, and I guess for this one you can get a special price, which is, yes, for this workshop we spread a special voucher what allows you to pass Cassandra certification and become a certified developer or administrator for free. Like literally paying nothing. We have free courses and now we sponsor certification, so you don't have to pay a cent. That's great. I love it. And we are done. So, Tomasz, I guess I handle that to you. Thank you. Yeah, I love this one. Yep. Thank you. A great, big pleasure to me. One side of my job, I'm organizing Cassandra Days globally. Currently, I'm working on Cassandra Day Russia, Cassandra Day Italy, Cassandra Day France. And I guess maybe a couple of months later, we have to talk about Cassandra Day Poland as well. Yeah, I know how to find you. As soon as I will have a moment, I will reach you. Thank you all.